everybody, welcome back to Baking Soda Central. We were discussing pH and how it is an Achilles heel for the coronavirus. As it turns out, the body is highly regulated by pH. Different aspects, parts of the body require different levels to function properly, as is the defense and management of bacteria and viruses. So when did we find out that some viruses were pH dependent, in particular a coronavirus? Well, Michael Crichton in 1969 wrote the book, The Andromeda Strain. It was written before Jurassic Park, and he wrote it out of medical school to pay off his bills. In it, an alien pathogen comes to Earth and is about to take over and kill everybody when the experts figure out that it is pH dependent, and they are about to give their victims and save the world by giving them bicarbonate of soda, when the plot takes a change. In medical literature, in 1978, Arius Helenius and colleagues who are virologists were at a conference in Berlin, and one said to the other, I wonder if could pH have something to do with host entry? They went on to do experiments on this, and they validated the hypothesis, to which he thought later, I have had many other turning points along my scientific path, but none of them was quite as significant, with as many significant consequences as the one involving endosomal entry of SFV, which was the virus they were studying, some linky forest virus, and the role of pH. Wouldn't you like to know what the significant consequences were from his point of view? In 1990, we included in a book my brother and I wrote, Conformational Change, in which the researchers, Lawrence Sternum and colleagues, determined that empirically, they start with, it is well known that the infectivity of coronavirus is most stable at pH 6 to 6.5. So it is well known in 1990. In marked contrast is the effect of treatment. So there seems to be ways of affecting this treatment at pH 8 and 37 degrees Celsius, so temperature is important, in which half the infectivity was lost in 1/2 hour. The rapid loss of infectivity at pH 8 was irreversible. In 2006, Dr. Chu and colleagues asked the question, we wish to determine if coronavirus fusion was pH dependent. Their studies revealed, we show here that fusion of coronavirus IBV with host cells does not occur at neutral pH 7, that fusion activation is a low pH dependent process, and they go down to 5.0 as the optimal zone. As such, the coronavirus IBV shows many similarities to pH dependent viruses. So a lot of viruses are pH dependent, such as influenza virus. Influenza? Well, that's a whole talk for another day. 2016, another study, St. Jude's Hospital, conclude the same thing, low pH dependent, 5.56, depending on what virus you're talking about. So just so we make sure we know what we're talking about here, we're familiar with the litmus chart and the pH scale. We're going from 0 to 14, 7 in the middle, neutral, acidic stuff, alkalinic stuff, and the coronavirus we're discussing here in this medium, which would be like a 5. Here's our coronavirus, here's our cell, and look at how happy. Whoa, it's so happy, and that environment's gonna latch right onto that cell there, take it over, infect it, and boom, make a whole lot more. Now, if we put it in a different environment though, we put it in that bluey 8, let's say the baking soda environment, not happy, nothing, can't do, can't latch, no triggers, no signals, nothing, useless. So that's my interpretation of how that looks. Some scientists can correct me, just an English major here. But let's think about what that might look like for the throat. So we have an area here that we have some access to. So let's suppose that you're a coffee drinker, like myself, and you have that coffee sitting on your throat all day long. Well, that's ode to the 5, isn't it? So I'm not saying don't drink the coffee, not my role, but maybe not all day long, keep it in that kind of environment, let alone Coke, which is 2. But then again, on the Andromeda strain theory, or that's on the other range, the other end, very acidic, that actually might not be a bad idea, but generally you don't make your body all that acidic. So let's think about going up the other side. Just plain water is neutral. Some countries like Japan gargle with water. But let's take it up a notch. Let's put a little bicarb in there. And I'm going to tell you why bicarb is particularly a winning idea in a second. So there we've got a little bit of bicarb, that wasn't much. And we put in our litmus. And boom, baby. You're up to 8, going up to 9. It's going to get a little darker as time goes on. So now you've got that beautiful alkaline environment. And so let's suppose you drank that, gargled with it a few times a day, go out and about. Doesn't that kind of make some sense? So that's what we're thinking about with the pH. The really nifty thing is that bicarbonate soda, we're calling baking soda, is sodium bicarbonate. It's a naturally produced substance. The body already makes it. It is already the main regulator in our body of this system. So sometimes we just need a little bit more. We are going to look next at the earlier history of pH and what people understood and how they used it in earlier decades, going back to the Spanish flu.